guys, so this video is on determining molecular formula when the empirical formula and the molar mass is given. Okay, so this is the equation we use. Molecular formula is equals to empirical formula multiplied by n. So what is this n? It is actually a factor. You multiply the empirical formula and with empirical formula to get the molecular formula. Okay, so if we know n, then we can figure out the molecular formula, because EF, which is empirical formula, is already given in the problem. In this case it is CH2O. So let me read the question. The empirical formula for fructose, which is a fruit sugar, is CH2O. Its experimental molar mass is 180.2 grams per mole. You have to determine the molecular formula for the compound. For this, let's figure out the n, and n is actually the experimental molar mass. So this is the ratio of the molar masses and the molar mass of empirical formula. So this one, experimental molar mass, already given in the problem. Okay guys, and to find this molar mass, you're going to use a periodic table, and this is already found here. I have used periodic table to figure out the molar mass of empirical formula. Here is the molar mass, and you already know how to figure out the molar mass. Let's now solve for n. Let's insert the values. So n equals to experimental molar mass, which is 180.2 grams per mole, okay, divided by molar mass of empirical formula that we just figured out. We have it here, 30.03. So guys, this will not be given to you. You will have to figure out. What is given in the problem is experimental molar mass. So 180.2, you're going to divide it by 30.03, and this same units in the numerator and denominator, you cross them out. When you divide these numbers, you're going to get 6. Now guys, you see this number should always be a whole number, okay, and it could be or very close to the whole number, so that you can round it off to the whole number. Next step is you're going to substitute this value of n, which is 6, in this original formula. So MF is equals to empirical formula. This is empirical formula, which is CH2O. I'm going to write here CH2O, and it says times n. So times, this is my n, so I'm going to write here 6. Next step, what do? Is you're going to multiply these subscripts for the empirical formula for each element by this factor n, okay, and as a result you are going to get C6H12O6, because 6 times 1 is 6, 6 times 2 is 12, and 6 times 1 is 6. Okay, so this is how you figure out the molecular formula. This is the molecular formula for sucrose, for fructose. Okay, now let's try one more problem. So a brown gas has the empirical formula of NO2. Its experimental molar mass is 46.0 grams per mole. You have to find the molecular formula. It's again the same thing. You are going to use the same formula. Molecular formula equals to empirical formula times n, and you know what to do. You multiply empirical formula with factor n to get the molecular formula. Okay, and to find the value of n, the experimental molar mass divided by molar mass of empirical formula. So if you forget, you can also refer here, experimental molar mass over molar mass of empirical formula. Okay guys, so what is the experimental molar mass? It is already given in the problem, which is 46.0 grams per mole, and molar mass of empirical formula You have figured this out. It's right here by using the periodic table. You have used the periodic table to figure out the molar mass of each element in that molecule. Okay, divided by 46.01 grams per mole. Cross it out, divide them, and you're going to get 1, which is your vector n. N can be 1, 2, 3 or other numbers. So here 1, it should be a whole number, and it is a whole number. The next part is that you substitute this value of n in the empirical formula right here. So this will be NO2 times n, which is my 1. Okay guys, so I'm just putting all these values, these numbers in this original formula. Molecular formula, here empirical formula. You write here NO2, and this n is 1 that you just figured out. Right? And what are you going to get? As a result, anything multiplied or divided by 1 always gives the same result. So the answer is NO2. What did you notice here? You have noticed that in this case, molecular formula is actually equals to the empirical formula. So it is possible that in some compounds, molecular formula is equals to empirical formula. And when it is not equals, in that case, the molecular formula will always be a simple multiple of empirical formula. Right? Now I want you to try this problem on your own. Let me hide it. So pause the video, try this problem on your own, okay? And double check everything. This is what you should be getting right here. And I have written all the steps, everything I was saying. And guys, also I have a summary about the molecular formula, its definition, its background info, and when you read, you're going to see we have covered everything in class, but I still want you to read it, every single thing from here. Okay, try more problems. Take care guys. I hope this was helpful. Thank you.